So next we come to the intensity of sound waves, and we're going to measure this in decibels. We're going to define a new unit of decibels. But first we'll understand what intensity itself is. Intensity is the rate of flow of energy per unit area. Okay, so rate of flow of energy, how much energy flows per how much time. Yeah, that's delta E over delta T, but the whole thing per unit area as well. So delta E over delta T we've come across before at the end of, I think, chapter on maybe energy, yeah, chapter 6. And we call that power. Yeah, so power divided by area is going to give us intensity. Power is in the unit of watts, so watts per meter squared is going to be our units for intensity. Okay. The faintest sound that you can hear, which was 0 decibels, is about 10 to the negative 12 watts per meter squared. So that's how much energy needs to flow per unit time, per unit area squared area for you to be able to hear it. Yeah? This is an important number. It's well worth having some familiarity with it. At the highest intensity that we can bear, it's about 1 watt per meter squared. So we're here in a range of 10 to the power 12. Yeah? That's a really wide range. If you needed to draw this range on a piece of paper, you would need a very, very long piece of paper if you go in units of 1 or 10 or whatever. Yeah. So whenever you have such a wide range, it's easier if you express it in terms of a logarithmic scale. Then you can plot that. It gets condensed onto a single piece of paper. Okay, so we'll find that we define a new unit, which is the decibel, which will be related to this unit of intensity. Yeah, so that it becomes more convenient. Okay, and that will be a logarithmic scale. So the ear is very, very sensitive to small pressure changes, so much so as 3 parts in 10 to the power 10. Yeah? So it's one of the last senses to go when people are in a coma, say. Yeah? So it's always good to talk to them. Okay. Intensity level of waves. Here we're defining the new scale, and we're going to give it this symbol beta. Okay, it's defined as 10 log of the intensity, its ratio to the threshold intensity, I divided by I0. So remember, the threshold was at 10 to the minus 12 watts per meter squared. And for any given intensity, you can find its decibel value by taking that ratio, then taking the log of the ratio. This means log to base 10, yeah, when we write log. Okay. So intensity is a real physical quantity. That's the energy rate being flown, the rate at which energy flows across a given area. Okay. The logarithmic scale, on the other hand, is an intensity level. Okay. So it's important to distinguish between these. What is intensity versus intensity level? Intensity level is going to be decibels. Okay. Intensity of a point source. So if you say that you have a point source, let's say here, okay, so this is my source of sound waves. They're coming out in all these different directions, 360 degrees, okay. Then the intensity varies with the distance as 1 over r squared. Here we come across another inverse square relationship. When we came across the first one in gravitation, I pointed out to you that you will come across this several times. Yeah. So let's just draw a surface some distance away. So a surface which is concentric at a uniform distance away is going to be a concentric circle or a sphere, right? Not great drawing there, but anyway. And let's say it's a distance r away. Then the intensity out here is proportional to the inverse of the radius squared. Yeah? Or if you have 2 different intensities, one at I1, you take another, maybe further out, another circle, and you call that I2. Then this is going to be proportional to R1 This one's going to be inversely proportional to R2 squared. Yeah, inversely proportional to R1 squared, inversely proportional to R2 squared. If you divide one by the other, you are going to get this expression. Okay. So you can use this to compare the intensity at two different places if you know their distances from the source. Let's do a simple problem about decibels. Okay. Given that I0 is the threshold of hearing, calculate its value in decibels. So you're going to find the decibel value, which was beta. What was the definition? 10 log of I divided by I0. Yeah? And now we need to find the intensity value of I0. So my I is I0. So the next step, you'd write this again. This time you write this as I0. Yeah? Which means these two are going to cancel out to give me 1. What is log of 1? Log of 1 is 0. Yeah? By definition. Therefore, beta is equal to 0 decibels. And decibel is written like this with a lowercase d and an uppercase b. Okay? So this whole thing is a decibel unit. And at the threshold, we have 0 decibels, which matches with what we learned before, that our range of hearing is from 0 decibels to 120 decibels. So it does need to start at 0. Now, I0 does need to correspond to 0 intensity level. And that's exactly what's shown here. On this chart, we see several different sources of sound, okay, and their actual intensities in watts per meter squared. The corresponding intensity level, which can be found using this formula in decibels, yeah? And each time we're going up by a factor of 10 in intensity. So 10 to the minus 12, the lowest sound intensity we can hear, something like the rustling of leaves. Yeah? If you go up by 100, you come to a whisper, 10 to the minus 10. That's about 20 decibels. Yeah? We've gone up by 100. Okay. If you go up further, another 10, we haven't written that here. Let's say you do busy street traffic, okay, like on a big street. That's roughly the order of 10 to the minus 5. These are all approximate values, which corresponds to 70 decibels. Okay, so we're just going up in units of 10 several times to give you some feel for the intensity and intensity levels. If you're at the front row of a rock concert, that's roughly 110, 120 decibels, close to the edge of the threshold of pain. Yeah? If you're exposed to it for too long, you may feel pain. At about 120 or 130 decibels, even at a short exposure, you're beginning to feel pain. And any higher than that, you're going to have perforation of your eardrum, which cannot be repaired. So when your parent used to tell you, when you were a teenager, to not listen to music so loud, they were right. Okay? So what did we learn? We learned the formula for intensity level. We know that this formula in the audible range needs to go from 0 decibels to 120 decibels. Okay? And each time that you multiply intensity by 10, the decibel level goes up, yeah, by 10 added decibels. Yeah? So you go from 10 to 20, 20 to 30, while you are multiplying by 10 at the intensity, watts per meter squared. How many decibels is the sound intensity level raised when intensity is doubled? Okay, so we just need our formula again. I've written it up here for you. The easiest way to do this, since no levels are given to you, is to just double the threshold intensity. So take I as I0, twice I0. Take I as twice I0. And then substitute that in the formula, and you will be able to solve it. and hopefully you will get the same result as me. So you should do that and then compare and find that you get 3 decibels. So when your intensity doubles, the intensity level only goes up by 3 decibels.